Hey guys, we're coming back to vectors, and today I'm going to consider vectors in their component forms. So what the component forms are, or what the components of the vector. If the vector is put on Cartesian plane on xy set, so basically this is 2D dimension, it will have two components. So one component is simply along x direction, and another component is along y direction. So that's the typical vector A. And if we want to set up A in its components form, we just simply say that, okay, it has AX and AY components, which simply comes from addition rule. You remember if you set up vector which is parallel to, let's set up like black color here. So if we set up one vector strictly along x direction and another vector strictly along y direction from there, so that they arrange head to tails, basically structure like a snake goes. Just remember all the previous videos. So we can say that simply we have vector AX that goes along x direction and vector AY that goes along y direction. But in terms of addition, definitely you can say that vector A is going to be the sum of AX and AY. Okay? In this case, we took two vectors that are perpendicular due to the fact that we have rectangular system, basically Cartesian plane represent two axes, x and y, that are perpendicular. And because we follow x direction here for ax and follow y direction for ay, we also have two perpendicular vectors. So in this case, using an addition rule for vectors, we can set up vector A as simply two vectors. Each one goes along x and y direction correspondingly. So that's why those ax and ay becomes components of the vector. But simply, instead of writing ax and ay, mathematicians used to write just simply x and y. So we can say that vector A will have simply x component and y component. And this is what is called column vector, because you see clearly as the structure, it represents the column. So this is the column vector. All right, or vector in its components. How to understand how we can get the component? Actually, just very cool trick. Let's say A is some object, real object, it might be a stick, and you put the light from the top. So you lit the light on this object from the top. So in this case, if this is the light, right, it goes from, it's basically parallel beams that falling down on the object. Yeah, sorry, that was my phone. And what about the shadows? Obviously, due to parallel beams that lit on this object A from the top, it will arrange the shadow below. And for example, if x-axis is the ground, let's say this is the ground, it simply will have a shadow with the length of from here to there. So basically from the starting point of the vector A or of that stick to the ending point of that stick here. The same you can do if you lit the light but from the left hand side. For example, from that tip along the stick and up to the top tip of the stick. So in this case, it will arrange shadow with the length equals to the y component of that vector. So basically, that's how you can understand what components are. So that's sort of applying physics here to the object with the light lid on it. Okay, so typically you can consider each component x and y as simply step, because obviously the step might be negative. Remember when we did translations, we translate an object or like triangle, line, no matter function, we translate some units to the right, to the left, or probably up and down. We actually understand that that transfer might be negative and positive in terms of how many units to the left or to the right it transferred the object. That's the same. So x and y components might be positive and negative. So hence, if we set up the vector, let's say another vector, let's take vector b with the components, let's take one negative, -1, and 2, we can say the following. If we have Cartesian plane, so right now I'm going to set up Cartesian planes right there. So in this case, this is y, this is x. We can take any starting point, no matter where you take it. Let's say here, okay? That's the starting point. Then we do -1 step. It means we just go backward here by 1 unit. That what -1 as x component means. And this becomes an x component for the vector b. So next, after that, we use again head to tail rule, and we step 2 units up. This is y component, so it's positive, so we goes up by 2 units from there. So we arrive to the final point, or to the destination point. We start from point A, and then we arrive to point B. So what can you say about this? We actually arrange right now, we arrange the vector AB, which is here, which is equal to our vector B. So that's how we can set up vector B in the component form. And if I use the green one, so I just simply connect starting point and ending point, and that's how I can arrange vector B. Okay, so now you can make any transfer. So no matter where you start, where you put the starting point A, you can put the starting point even here, even there. It won't have any effect on the coordinates. So the coordinates of the vector will still be -1 and 2, no matter where you arrange the inception of that vector. Okay, your vector can emanate in any point. So, however, using components, you will always get your vectors. So, for example, if you use that starting point, you always get vector B by taking -1, taken away basically from x direction by 1 unit and 2 units up. Okay, so that's how it works. So this is going to be a y component, by the way. So that's y component. So that's how typically you can construct the vector. But what if you're given some points? Let's say you're given some points. In this case, I just simply demonstrate how it might work. If you have, let's say, 2 points and you want to arrange the vector using the starting point and ending point. So let's say we've got, seems to me it's better to transfer like this. Okay, so that to have the same font type. All right, so here let's say we are given 2 points. Point A with coordinates 2 and 3, and we have point B with coordinates, let's say, -1 and -3. So we need to find vector AB first. And let's say we need to find vector BA. as a negative, as you remember. So BA is basically the negative vector for AB, or it's simply opposite. Okay, so how we can do that? First of all, we need to set up Cartesian plane in order to work with components. Okay, so, and in order to work with points, so right now we've got y and x direction. So, and we want to set up, this is the origin, we first set up point A with coordinates 2 and 3. So it's here, 2 and 3. So that's our point A. Okay, what about point B? It's -1 and -3. So -3 for y and -1 for x. -1 and -3, it's here. So we've got point B here. All right, so that's point B. What we need to do? Actually, we need to just connect those 2 points with a vector. Let's set up that color. And vector AB is going to be that vector, okay? Now, let's have a look at the components. So what we can do, what we know about components. So I use black one, and let's use dashed line. So this is going to be a y component, it goes down. And this is going to be x components. Let's estimate the length of each component. So the y component goes from the level of 3 down, so it's going to be negative definitely because its direction is opposed to y direction. And for how long? Goes to the level of -3. So that's the level of -3. So it goes by, it actually goes by 6 units down. So that's why if we write AB in terms of the components, we understand that y component is going to be just 6 units. And because it goes down in the opposite direction of y-axis, it's going to be -6. Okay, so we've got simply y component as -6. All right, so what about x component? It starts from 2 and goes to -1. It's also negative, so that's why from 2 to -1, we go actually 3 units, but in the direction opposite that opposed to x direction. So in this case, it's going to be -3 as well. So completely, our vector AB will have -3 as the x component and -6 as y component. So actually, if you work out those values from in this way that actually I showed you, so you understand that in order to find x components, if you're given 2 points A and B, and you want to find, let's say, x components, what do you actually need to do? You need to subtract from the ending x components, in this case it's -1, you need to subtract the starting x component too. In this case, -3 is simply -1 from there, from the ending point B, and you subtract 2, the x components of the starting point A. Okay, so what about, and the result is going to be -3. So what about -6? How you arrive to -6? So you actually subtract from -3, this is the y component, again, of the ending point. So this is the y component of the ending point, is -3. You subtract the ending y coordinate of the ending point, of the starting point A. So that's why you simply subtract 3 again, and that's how you arrive to -6. So here's the general rule. In order to use an alternative way, if you're given 2 points with coordinates, let's say 2, 3, and -1 and -3, in order to calculate each component of the vector, you simply need to subtract corresponding coordinates from the ending position, corresponding coordinates of the starting position. So how we can arrange as a general rule. So if you have a look there, you can say in general that if you have coordinate point A with coordinates, let's say A1, or better to say x1, yeah. So x1 and y1 a starting point. This is starting point. You have ending point with coordinates x2 and y2. That's ending point. In order to figure out vector that emanates in A and ends up in B, so basically vector AB, you just simply need to make the difference of the components. So if you want to figure out x component, it's going to be the x2, the coordinates of the ending point B, and you simply subtract the starting point x1 coordinates. So what about y component? You do the same for y's. So you basically making the difference. And that's how you come to changing x and changing y. Similar to what you had when you had to deal with actually the gradient of the line. So if you remember what the gradient of the line, this is basically changing x and changing y along the direction of the line, right? So that's simply the same. So according to what we have, if we want to set up like the rule according to general rule for points A and B, if this is Cartesian plane and we set up 2 points, let's say A and B, and we want to calculate vector in component form that goes from A to B, basically vector AB, we just simply need to say that, okay, we have change in x, it's here, and change in y, it's a vertical component or y component for our resultant vector AB. So that's delta x and that's delta y. So that's how it works practically. So, and for example, if you want to do this trick with the following example, let's say coordinates A 2, -3, and let's take coordinates B as 3 and 1, and we want to figure out vector AB and its component form. You just simply need to use B is the ending point in this case, so B, this is the ending point, and A is the starting point. So you simply subtract from the ending point 3, you subtract x component of the starting point 2, and you do the same for y. So it's 1 ending y coordinates, and you subtract starting point. So starting point y coordinate is -3, so that's why you have double minus here. And if you calculate, you figure out that it's 1 and 4. So vector AB is going to be as 1 and 4. Okay, so but what about vector BA? You simply need to swap the coordinates. I mean, what does mean swap? Not swap the coordinates, but you need to swap the signs before them. So that's why you just simply put -1 and -4 for each corresponding component of the vector. If you are not sure, just try to check. So in case of BA, we're going to subtract from A coordinates, B coordinates. So in this case, it's going to be 2 minus 3, and for y, it's going to be -3 and -1. And actually, you'll come to -1 and -4 that we had using just by swapping the signs. Okay, so let's move up a little bit. In this case, we are actually supposed to do the same. So the second part of exercise was to find vector BA. So once we found AB, we can basically swap the signs and hence figure out the value of the components for vector BA. That's an opposite one, so it's going to be 3 and 6. And technically, it will go vice versa, so I'm going to use red color. So it will go in that way. The lengths of course be the same, however, the components will be opposite in signs. So hence, generally, you can write that vector BA is simply as the minus vector AB. So that's how it works. All right, guys, hope you understand that. That was vectors in components form, so you can explore it one more time. So if you're not sure how to do, but it's pretty easy. And actually, having some experience with straight lines, you understand that actually the vector, it's very similar to the directed straight line, because in this case, so you clearly see that components, as you can consider components, basically steps from starting point to the ending point along the direction of the line. Here is sort of analogy. Okay, so actually I'll show maybe more examples. Probably we can consider some examples from physics, because you understand in physics you use vectors for vector quantities, like for example for velocities, for accelerations. So for displacement, they are all kinematic values and kinematic physical quantities. And also if you go to electricity, for example, you can use also different forces like Coulomb force, magnetic force, actually. So but mostly that's you're concerned about Coulomb force as the force of interaction between two types of charges, and they might be the same type of charges like positive and positive, or they might be negative and positive, so different types. And here I also can have vectors. So about magnetic force, do the same. So it's about magnetic field strength, H, that how you can calculate that. And the same analogy for electricity. So here are lots of examples. And even in math and geometry, you will encounter with lots of examples there. So which will be based either on components form, or it will be based on basically addition, subtraction vectors. All right. Thank you guys. That was Daniel Dallas. See you later.